And we are live. Welcome for another session of the Virtual IoT Meetup. Today I'm joined by my colleague, Ian Scarrett. We're going to talk about Industry 4.0. There's a lot going on. I mean, you might not actually know what Industry 4.0 means, so I won't spoil Ian's presentation. I'll tell you more about it. But let's say that it's going to be about industrial IoT and all things open source for industrial IoT. So as always, and I want to make sure that you guys remember that this is an interactive session. So if you have any questions, just use the chat on YouTube. That's probably the best way to interact with us. Any question for Ian, just put it in the chat and we'll make sure to get that answered. You can also tweet if you want to use the virtual IoT hashtag. And that's it for the general announcements. Without further ado, Ian, why don't you briefly tell us all about Industry 4.0 and open source?
Great. Well, thank you, Benjamin, and it's great to be here. I think the last time I did a virtual IoT meetup was a couple of years ago, so it's nice to be back. I'm going to share my screen. And Benjamin, can you let me know if it went through?
Yeah, perfect.
Okay, perfect. So thank you for having me. And just by way of introduction, I'm the Vice President of Marketing for the Eclipse Foundation. But I spend a lot of my time with Benjamin and Roxanne on our IoT community. And one of the kind of the areas of IoT that I think is really fascinating and where I think kind of where the important kind of action is happening around IoT is the industrial IoT. And so we at the Eclipse IoT working group kind of have been talking about and focusing on what are the open source solutions that Industry 4.0 solution providers really need. And so what I want to do is kind of go through some of the thoughts that we have on that, and certainly I'm hoping there's lots of questions and feedback on this approach. It's definitely we're just definitely getting going on this, but so far the feedback's been really positive. So in terms of okay, let me there we go. Kind of what is Industry 4.0? And there's kind of some people call this smart manufacturing. Some people will call it Industry 4.0 in terms of a German spelling. And really the term does come out of Germany, from what I can tell, where the German kind of manufacturing industry, which is kind of really world-renowned in terms of the influence in the manufacturing industry, has kind of come together and said, okay, what's kind of next for manufacturing? And kind of they really think of this as being kind of the next revolution, the next industrial revolution. So if you think of kind of the first revolution being kind of mechanical and kind of mechanicalization of manufacturing with water and power through steam, and then kind of the second revolution was mass production. Third revolution is kind of the computerization, automation of manufacturing, and they really see that kind of the fourth revolution is really going to be around IoT or cyber physical systems, and so that's where the name comes from. But kind of what are the drivers and kind of why is this important? So I think the first thing is that kind of from a predictive maintenance, right? So a manufacturing factory floors, right? They're very equipment intensive, right? And if you can start to predict when a machine is going to go down in advance, that's a huge win, right? So if you kind of one of the big concerns of any factory floor is downtime. You want to minimize downtime, and so if you can start to predict when you need maintenance in advance of downtime, that's hugely important. The other thing is that just from a kind of a customer demand and business demand, they're really trying to look at how to be more flexible in terms of the manufacturing setup and kind of really respond to kind of mass customization. And so instead of spending millions of dollars to set up a factory line, that has to produce thousands of units. What they want to be able to do is get it so it's flexible enough that they can do kind of lot size one. So a factory line is set up that's just producing one unit, and then it's changed for different units. So much more flexible. And you can imagine that creates from the downstream demand a lot more flexibility. And the third thing is certainly kind of the further integration of the global supply chain. Right, so manufacturing, kind of with just power manufacturing, and is become much more integrated. And so, can Industry 4.0 take it to the next step? And finally, I think kind of the fourth major driver that I see for around Industry 4.0 is how to kind of improve safety and productivity. I think kind of coming from an enterprise software perspective, where it's not that kind of the safety and productivity of the humans working on the factory line. Like kind of, if a machine goes bad or kind of does something and kind of breaks, and it could seriously injure someone or kill someone, right? So how do you start? How can you improve the safety of the and the productivity of the people working in the factory? So with these drivers, that this kind of turns out to be a huge industry. I think that's one of the motivations we have within the IoT working group to focus on Industry 4.0 is that we really see that having good solutions for Industry 4.0 can have a significant impact on this significant industry. So there's a couple of challenges though. And I think kind of there's probably not more than a couple, but kind of two things that I just wanted to point out, right, is that really what Industry 4.0 is about is taking the operational technology, so the technology that's used on the factory floor, and integrating it with the enterprise IT, bringing these two sides much closer together. And the challenge to do that, there's a number of challenges. Like these two organizations within a bigger company often aren't well integrated, but this is really what Industry 4.0 is kind of leading to. But each of these groups have come from a different perspective, right? So from an operational technology, from kind of the people that are doing technology for the factory floor, right? Things like continuity, efficiency, safety are incredibly important. Like those values drive their decision making in terms of technology. Enterprise IT, it's all about speed, time to market, agility, and the total cost of ownership, the ROI on making investments in technology. And so there's a bit of a mismatch in the values and kind of the pressures that these groups come under. And I think that's an important consideration to be thinking about when looking at Industry 4.0 solutions. The other kind of key consideration in my mind is that a lot of these Industry 4.0 scenarios are brownfield, right? Like you're not going to kind of completely rip and replace a factory just because you want to get better MQTT messages coming off a PLC, right? It's just not feasible, right? And so there's certainly new factories, there's certainly greenfield scenarios here, but brownfield scenarios are incredibly important. Is certainly in the short term of how to address the brownfield. And with brownfield comes their own set of challenges, right? Because a lot of the equipment in factories aren't internet enabled, right? They're based on proprietary technology that are very closed. So it makes it presents a kind of completely new set of challenges for bringing it all together. And we'll talk a bit about that later in the presentation. So in terms of kind of an architecture, what we see is like certainly kind of, so PLC, for people new to this domain, PLC stands for Programmable Logical Controller. Right, so it's kind of the embedded system that's running on a piece of factory equipment. And so certainly there's old PLCs, existing PLCs in a brownfield. Certainly some of the more modern PLCs coming out have much more capability, much more open, and internet enabled. So typically you'd see the old PLCs, some type of gateway being put in front of them to kind of sniff the information coming off, if you can get the information off, and feeding the information to some type of local IoT platform. Because in terms of safety, we're seeing more and more that it's important to have some type of processing within the factory, because the firewalls might not be open, they might not want to share the information outside of the factory. So there's a lot of safety concerns and privacy concerns around that. But there is some type of integration required with the enterprise IT. And typically a large organization is going to have multiple factories. So how do you bring together the information from multiple factories? And then so from this architecture, kind of prototypical architecture, there's three things that we think are important. One is interoperable. That how do you get the different PLCs that are within, so usually from different manufacturers, can talk to each other. How do you get them to talk to the gateways? How do you get them to talk to the platforms? That it needs to be distributed, right? So you need to be able to push processing out to the factories, out to the edge and into the gateways. And it needs to be scalable, right? That for large scale manufacturing, you're going to have lots of events, lots of data coming. So how do you scale this up in a reliable way? Because if you look at kind of efficiency and downtime for the factory, if your kind of Industry 4.0 solution goes down and your factory goes down, that's just not doable. So some considerations for the architecture. And then what we said, like, what are the key software features to consider for an Industry 4.0 solution? And we really think there's 6 main features that kind of get introduced into this type of scenario. One is around data aggregation. So what's the software required to get the data off the PLCs to a gateway to the back end? And we'll go through a bit of that. How do you manage the devices once they're out there? Many scenarios for device management, there's like kind of remote device management is non-existent. So you actually kind of go up to the PLC with a computer and just connect directly to locally to the computer, to the piece of equipment. So how do you do remote device management? How do you handle the large-scale event management that integrates into your enterprise IT? How do you take all that analysis data and kind of make it useful data and kind of get analysis and action based on that data? And then certainly security is important. And finally, in terms of, there's a concept that's really been driven in the industrial space called digital twin management, where to kind of simplify the interaction of setting up one of these, how can you start to model and simulate equipment in the digital world and then manage it once it's deployed from a digital twin. So,
Ian, if you don't mind me interrupting, it looks like your audio is not that great. Do you mind maybe switching to a different microphone? It looks like it might be a headset issue.
Shoot. Okay, let me just 1 second. Okay, does that sound better?
I am not sure. Let's see. Maybe if you speak slightly louder, maybe it'll help.
Okay.
Let's try one more time. Just FYI, as so we have lots of people are already engaging in the chat, and there's some people who are particularly interested in everything security for Industry 4.0. So just FYI, and I know you will be saying more about this, and we can certainly discuss more at the very end.
Good. Okay. Yeah, we've got a slide on security, so we'll get into that. So I think for the next part of the presentation, what I want to do is go through and talk about how the Eclipse IoT community can be a supplier of some of the software features that I presented. So Benjamin, is the audio better now, or do you want me to just completely switch over?
I think it's not perfect. It sounds slightly better. Yeah, let's just give it a few minutes, and if it just yeah, let's see. I think it's better.
Okay. All right. So quick introduction for the Eclipse IoT community. We have been in. So lots of people know about Eclipse as being for tools platform, but the Eclipse IoT community started well over 5 years ago. We're up to now 30 different open source projects focused on IoT, well over 2 million lines of code across all these projects, well over 250 developers who are working on the different projects and contributing to the projects. And an active online community of people coming and understanding through our websites what Eclipse IoT has to offer. So it's a well-established community. I would say it's probably the largest IoT open source community out there today. And so, as I said in my introduction, we've been focused on Industry 4.0. And so what I want to do is kind of go through what we provide from those 6 software features that we laid out. So Benjamin, I'm just going to pause there just to make sure. I want to be sensitive of the audio.
Yeah, I think it's all right. People seem to.
Okay, so I'll keep on going.
Happy with that.
So in terms of data aggregation, one of the things that we do is, we're a big believer is that open standards and open source implementation are really important in terms of adoption of technology. And so one of the open standards that's very popular in Industry 4.0 is OPC UA. This is a protocol and standard that's been out there that really talks about communication between the equipment for industrial automation equipment. And so within the Eclipse IoT community, we have a project called Eclipse Milo. That is a Java implementation of the OPC UA stack. It includes the client and server. And so there's a number of OPC UA implementations out there. I think this one is actually well considered in that community for being a production-ready implementation. It's licensed under the Eclipse public license, so it's a weak copyleft, so it's easily used in commercial implementations. And in fact, it is today used in commercial implementations. We also have an implementation of MQTT, which is another messaging protocol for IoT. So it's more general purpose protocol that Eclipse PAHO has the client implementations for MQTT across different language implementations. So Java, C, JavaScript, Python. I think there's a Go implementation coming. And Eclipse Mosquito is an MQTT broker written in C. So if you're interested in incorporating MQTT into your Industry 4.0 application, we have implementations that you could use. The other thing that we have is a project called Eclipse Unite, which is an implementation of a new standard called PPMP, so Production Performance Management Protocol. And this is a protocol coming out of Bosch Software Innovations. And really, they kind of saw within their factory setting that they needed to have a very simple kind of data format of the machine data that's coming off all their different factories. And so they came up with a protocol to do that. So it's a very simple data format that provides the important information required and gives them a consistent kind of format for their data for doing the analysis on the back end. And so they've been very successful in kind of making PPMP available for different types of PLCs in the industry. And we'll talk a bit about a testbed that we've done showcasing PPMP in Eclipse Unite. The other thing around for data aggregation is actually doing PLC development. So as I said before, in Greenfield's scenario, there's a lot of legacy PLCs out there that are very closed and proprietary, that doing the development on these PLCs is not kind of straightforward. So there's actually a new standard, a relatively new standard, an IEC standard called 61499, that really sets how you do PLC development and how you do distributed development for PLCs. And within the Eclipse community, we have a project called Eclipse 40ac, which basically provides the tooling and the runtimes for that standard. And I think this is a really important project in terms of the future for PLC development, where you can actually now start running and deploying open source code onto PLCs. And that makes kind of these PLCs and kind of more modern PLCs much more open to innovation. Now, that being said, kind of the safety critical nature of these machines are incredibly important. So I don't foresee this being kind of like the web, where it's completely open. There will be controls put on what can get targeted to PLCs, but having the freedom to experiment and to do development for PLCs, I think is going to be incredibly important in this industry. In terms of gateway, so we're kind of on, if you remember from a typical architecture, you would often in Greenfields put a gateway into an Industry 4.0 architecture. So we have a project called Eclipse Cura, and Eclipse Cura is an IoT gateway that allows a very flexible interface for doing northbound and southbound protocol support. So Eclipse Cura out of the box provides support for Modbus, OPC UA, just adding Siemens S7. But more importantly is that if there's a protocol out there that you want to have support, you can write your own driver and driver support for that protocol. So it's quite flexible. It talks northbound using MQTT to different cloud platforms. So it can be hooked up to Microsoft Azure, Amazon AWS IoT. It can hook into Eclipse Kapua, which is our IoT cloud platform that we'll talk about a bit about later. So from data aggregation to device management. And I think it's incredibly important that for Industry 4.0 solutions to scale, that remote updating configuration of devices is feasible. And there's another standard from the OMA called Lightweight M2M that provides a standard for doing device management, for how to kind of configure a device remotely, to spin up a new device, to shut down devices, but in a remote fashion. So within the Eclipse IoT community, we have two implementations of Lightweight M2M. Eclipse Lesson is a Java implementation, and mostly focused on the server, but does have client implementations. And then Eclipse Wakayama is a C implementation that's suited for the client. It can be used to start to build a server if you want to see server. So if you're interested in device management around Lightweight M2M, these two projects would certainly help start with a solution in Industry 4.0. The other area in device management is doing software update. And so we have a project called Eclipse Hawkbit that really deals with the back-end services required for doing software update. So Hawkbit is essentially an update server that keeps track of all the devices that are out there. It's a kind of a device repository that tracks what level of version of the software that each device has. But then it also allows you to manage and orchestrate the rollouts of new updates to these devices. So if you wanted to say, okay, in this factory, we're going to update this factory today and this factory next month, you can do that. It doesn't do the over-the-air update itself, it actually supports different over-the-air update protocols. So it supports lightweight M2M, and supports the OMA-DM. But again, it's an extensible interface that you can plug in your own proprietary interface or another over-the-air update protocol. Now, security. So to be brutally honest, I don't think we're there on security for Industry 4.0. So I'm afraid to disappoint everyone that's asking questions on YouTube. But here's what we have today. In terms of edge computing, if you're deploying code out to the edge, you need to be able to sign it, because you don't want to have kind of a third party deploying code and taking over your machine. And so if you're using something like Eclipse Cura, it supports code signing of the deployed code. So you can ensure that the code that's deployed out there is properly, if it's properly signed, it's from the organization that has a kind of the authority to put code out there. So I think that's an important step in terms of the reliability and security of the total system. In terms of authentication of devices, things like HANA, which we'll talk about in a bit, and Hawkbit support device authentication. And so you can ensure that kind of the devices in your network are trusted. And then finally, we have for access control, we have a project that's just coming on stream called Eclipse Kitty that starts just to provide a more simplified framework for doing access control across different devices and back-end user roles. So that's where we are for security. I think there's a long ways to go in terms of more complete solution and integrated solution. But from the perspective where we are today, this is what we have. And in fact, I think if you look at across the industry, there's a long ways to go to having the technology of going from the device all the way to the back end in a simple way. In terms of event management, so if you imagine you have hundreds of thousands of events coming in from different factories around the world with data, how do you integrate that in a scalable way into your back end? And the events are coming with different protocols from different types of factories and different types of equipment. So Eclipse HANA is really an effort to provide the glue layer between kind of protocol adapters in the devices and providing a consistent interface to your back end. And so what it does is it's a flexible interface that you can write your own protocol adapters. The ones that the support not right now are HTTP and MQTT. And it basically takes those adapters, convert the events into AMQP messages that work with a device registry and authentication service that we talked about to ensure that the devices are kind of what you're expecting. And then it exposes through REST APIs those events to the back end. So instead of kind of your ERP or SCM system having to kind of understand MQTT messages and lightweight M2M messages, right? It now just looks at AMQP messages and to the back end. And it's both ways. So you can send out control message going back to the devices too. In terms of an IoT cloud platform, so kind of how do you start to bring some of this together? And in terms of, especially around data management and analysis, we have a project called Eclipse Kapua, which is really a platform for hosting microservices of different functionality that you need for doing IoT, an IoT cloud platform. So you can imagine things like Lesson for doing device management, Hawkbit for doing the software update, being microservices running on Kapua in an integrated fashion. Similar with HANA would be there. So this is a project that's coming on stream. They've done their alpha release, and it's an area that we are really encouraged by in terms of providing a more integrated platform for the cloud and this cloud, and where things like kind of a Cloudera or kind of just a straight up Hadoop instance and visualization can start to integrate into for doing a total solution. And then finally, we have just a new project coming in. We just got the code is just getting coming into the repository. It's called Eclipse Ditto. This is actually a new project being proposed and organized by Bosch again, and it's really to provide kind of this kind of framework for kind of managing physical devices in the digital world. And so, how can you abstract out kind of all the information in terms of kind of the meta information in terms of the function blocks and data, but how are the devices connected to each other, right? And then from there, you can start to do simulation and manage it once in deployment. So Ditto's a new project, and I think there's a lot of conversation in the industry about digital twin, and frankly, I don't think it's that well defined yet. But I think it's certainly promising in terms of starting to simplify how you build and manage these types of solutions. So what I kind of changed gears a bit. So that's kind of from a project perspective what we're doing. But within the Eclipse IoT community, we also are starting to do test beds. And I think of test beds as a way to showcase how all this technology can come together and how different companies can participate to provide a solution. Because frankly, in kind of no industry production, no company or no open source community can provide a complete solution by themselves. It really does take a supply or an ecosystem of companies and open source technology to do that. And so we started building test beds, and the test beds are really around an industry problem and industry application. And so for Industry 4.0, we just in the end of October announced a test bed to really look at how do you take different equipment, industrial equipment that's out in the factory floors, and having it provide kind of a consistent information in a consistent format to the back end, so you can start doing things like predictive maintenance. Because if you have one kind of piece of equipment providing information and kind of the temperature information in a different format from another one, then bringing all that information together to do the analysis becomes a lot more problematic. And so we wanted to kind of set up a system on how to do that. And so the solution that we've looking at, and I alluded to this earlier in the presentation, was around the protocol PPMP, where we take PPMP and deploy it on a number of different devices, and kind of start looking at kind of different sensors on these devices to monitor things like power consumption, temperature, vibration, and send it in a consistent format to a backend, an IoT cloud platform that has a set of REST APIs that we can use to do dashboards and some analysis for predictive maintenance. So that's kind of the solution that we looked at. This is what we provided. I'm not going to go in a lot more detail this, but kind of essentially we wired up 40AC to be able to create PPMP messages for different PLCs. We took Cura that can speak OPC using Milo and made Cura to be able to generate PPMP messages and send all those messages to an InfluxDB database that was able to then kind of bring the data all together and use something like Grafana to do the dashboards. Nice thing is that we had a number of kind of some key industry members participate in this. So Contact Software is a well-regarded PLM vendor in Germany. Bosch is one of the major industrial companies in the world working on this. Fortis is a research institute in Germany. Eurotech provides industrial quality gateways for factories and for Industry 4.0. The Influx Data is the company behind Influx DB. And so these five companies came together to provide this testbed. If you go, I should have put the URL to it, but if this is all online, maybe at the end, Benjamin, you can put a URL to the testbed if people are interested. The important thing is that we made the code available, so if you want to download it, you can see it. And finally, we actually wrote a white paper around Industry 4.0 and open source software. So I encourage you to take a look at that. It covers a lot of what I presented and went through in this presentation. And the feedback has been very positive on it. So we can also give a link to that. And in conclusion, this is a community. We're a community of some pretty impressive companies working in IoT. And so welcome to join us. But also in general, I always like to kind of finish a presentation encouraging everyone to get involved in the Eclipse IoT community. Kind of just learning and using the Eclipse IoT projects. If you like what you see, kind of start providing feedback, open bugs, write articles about it. There are great contributions to open source. Certainly, if you found a bug, provide a fix, write a feature I think would be really well received. Our projects are always looking for developers who want to become committers, who want to commit time to making sure this project is successful. So kind of if you're kind of interested in kind of a longer term, more serious commitment to a project, please approach them. We're always looking for new IoT projects, so feel free to talk to Benjamin or myself. And we're always looking for more companies to join the IoT working group. We're going to be doing more test beds, so if you want to work with us on a test bed in Industry 4.0 or other areas, please come and talk to us. So that's it. That's what I have. Benjamin, I'm hoping there's some questions, or we can just chat about what's next for the community too.
Well, let's start with some questions indeed. Ali actually has several questions, which I may summarize actually under the same umbrella. I mean, it started with a question like, is Mosquito the only broker provided by Eclipse IoT, and other questions around basically all our projects and whether they are meant to be the best implementations out there, or if they are more sort of a reference implementations. And this applies to Kura, Kapua, Hono. So what's your take on this, Ian?
So let's deal with kind of Mosquito question first. So there's definitely other implementations of open source implementations of MQTT outside the Eclipse IoT community. Within the Eclipse IoT community, Mosquito is our only broker. That being said, I would welcome other implementations. So I'd love to get a Java implementation. I'd love to get a Go implementation of an MQTT broker. But Mosquito is the only one we have today. In terms of kind of, let me just restate kind of the question. Maybe kind of what's the expectation of the kind of the quality of the project? Maybe is what I heard. So for me, for the Eclipse Foundation, and this is general to most of our projects, one of our goals is to have our technology used in commercial products, right? To me, that's considered success for our project. So we have expectations that projects are achieving production quality for their technology. And if you look at Cura, like Cura is absolutely used in production today, right? And has been for many years. And Leshen is being used in production. But that being said, like not all projects are there yet, right? So and we always look for kind of ways to try and communicate this, and it's because production quality is also not as a beholder too, right? It's kind of what's good enough for your scenario. So I think so Cure is definitely there. Kapua is probably a bit early. Benjamin, what were the other projects he listed?
For edge computing, yeah, Cura, Kapua, Hono.
Yeah, so Cure is definitely there. Kapua and Hono are still early days for them, right? So I think what I would suggest, if you're interested in that functionality, they definitely have downloads. You can definitely kind of look at them and experiment with them. And frankly, if you think they're good enough, then you're free to use them in production. But my sense is they're not there yet. And so they would welcome the feedback on what they want to. I can tell you there's the companies behind those projects definitely plan to take them into production, right? So there is a plan to get to production quality, but not yet.
Well, maybe actually along those lines, there's and on the topic of security, what's your take on how do people take open source software and run it in production in a secured fashion, right? I mean, we've talked about some open source projects that explicitly address security and are in for security, but for all the rest, how do you make it secure?
Well, I don't think there's any. It's the same way you would do kind of commercial software too, right? You're doing security audits, and you have security experts doing the analysis and the testing to that, right? So I don't think open source kind of is any different from that. It's just a different source of technology that you would be using. Benjamin, you feel free, Benjamin, if you have.
No, I absolutely agree. Like, I mean, when someone sources software, be it open source software, commercial software, one still has to do some due diligence and figure out what are the requirements and what's a good level of confidence when it comes to security. Are there particular standards that are maybe relevant to a particular industry? Are there humans involved in the solution that's going to be operated by the software or not? Like, yep. So,
yep. Okay.
There's a question which I think can probably be generalized beyond DITO, but the question is around DITO and whether there is a standard behind DITO.
There is not, that I know of. Like, so I think, as I kind of alluded to this during the presentation, the term digital twin is being used more and more in the industry. And I don't claim to be an expert on this area, but my impression is that the way people talk about it and use the term depends. It's very different from vendor and supplier to vendor to vendor. And so I don't know of any standard effort around it, and I don't know if anyone even kind of starting to think about it yet. So it's very early days in this area.
Yeah, one area might be under the one M2M umbrella. I wonder if there's anything going on there around digital twin. But like you said, like it's a very wide domain. Yeah. So yeah. I think that's a question, I guess, from me and to both you, Ian, and maybe to the audience. We've talked about quite a few protocols like MQTT and lightweight M2M, OPC, etc. Ian, do you see other protocols on your radar for Industry 4.0? And to the audience, do you guys care about other industrial protocols for which you would hope maybe to see a better and a stronger open source ecosystem?
So I think what I would like to see within the Eclipse IoT community is the different field support for the different field protocols that are out there, so the different PLCs that are out there. I'd love to be able to kind of see a wider portfolio of implementations that people can use in open source. So we have OPC UA. Right? Are there others out there that should be implemented in open source? I think is it MT Connect, right? Another one, and PAC-ML is right. Can we get those types of implementations? I think would be important. But I agree. Like I'd love to kind of hear what other people think too.
Yeah, well, so people watching the webinar, feel free to comment on the chat. Yeah, I think there's like certainly lots of verticals. We see lots of consolidation in terms of IoT protocols, I would say, and like for the communication between the edge of the network and the cloud. But in the field, there will always be like dedicated protocols for, say, building management or for packaging, like you said, Ian. So, yeah, I would be really interested in hearing your thoughts on that. Was there other? Well, actually, I think we are slowly reaching the end of the presentation, and at least so far, reaching the. We don't have any more questions that I see, at least. So if I missed any question, people in the chat, please let me know. Let us know. We still have a few minutes, which I will be using actually to remind you that today is the last day to apply for the Open IoT Challenge. This is something we've been doing for 4 years now, or at least this is the 4th edition. So I'm assuming many of you guys are familiar with it, but essentially the idea is this is a developer challenge. You need to apply and tell us what you plan on building in terms of a cool IoT solution. The IoT solution that you will be building will have to be based on open source software. We want to sort of demonstrate the power of building IoT solutions on top of open technology and open standards. So check out iot.eclipse.org/open IoT challenge. You can team up with your friends, and basically you will have about 3 months to build your solution. We'll be awarding some cool hardware to the 10 best proposals. And in any case, even if you're not part of the best 10 proposals, you can still, of course, work towards building the best solution overall, which will be announced early next year. So you can build your project, blog about it, use our Slack channel to interact with others, and this should be fun. And I'm particularly interested actually in seeing projects that would be targeting industry use cases. So all the projects that Ian mentioned, like 4DIAC and Currentito, would be really good to see. So thanks, Ian. You basically you popped up the webpage in the meantime. So check it out. I actually realized in the meantime that I missed a question, one more question from Ali around security still. And is there any kind of encryption for the IoT communications that's being implemented for security reasons?
So we have an implementation of DTLS, which in a project called Tiny DTLS. But other than that, Benjamin, I'm kind of trying to think, is there anything else that?
I mean, like, communication-wise, we usually rely on TLS, SSL, basically, or DTLS for securing the communications, and you can do MQTT over TLS, you can do OPC UA over TLS, and you can even like have certificate-based mutual authentication of the client, the servers. there's and there's stuff available at Eclipse for that, or there's like SSL implementations out there as well. Well, with that, I think that's it for today. Actually, Ian, thanks very much. Many people actually have been asking for the slides, so we will be posting the link to those in the comments on the video, as well as on Meetup. Any follow-up questions? You have Ian's contact in the slides as well, and I think you guys all know where to find us. We will be back in about 2 weeks' time on December the 6th for a. I'm actually really looking forward to this presentation from Intel on hardware abstraction libraries. You may know that Intel has some cool open source projects for IoT. Among which some good stuff for sensor abstraction and sensor drivers. So we'll be happy to have Intel on December the 6th. Feel free to already RSVP. As always, other topics you would like us to cover, please tell us. Like we're trying to create and to craft the best program and the best sessions for you, but we're always looking forward to get your feedback. So I think that's it. That's it for today. That's what I had. Ian, some final comments from you?
No. Thank you for joining us. It would be great if you have any questions or you want to get involved. We're always looking to welcome more projects and more companies who are interested in working around open source and IoT, and in this case, Industry 4.0.
Yep. Well, thanks very much for joining us today. And like we said, that line shortly, and so we'll the recording. So even if you missed the beginning, you can of the session, or you missed it altogether, you can watch it. Thanks, and we'll be back on December the 6th. Bye.
Thanks, Benjamin.